There we go. So we're recording the virtual roundtable on Story of a Part of Women in 3D Printing Israel. And we'll start in just 30 seconds. We'll just let people come on from Eventbrite, because it does take a few clicks. So we'll be a little bit patient for like 5 more seconds. There we go. All right, so welcome everybody, and thank you so much for joining us on this Women in 3D Printing virtual roundtable. Our topic today is, to me, a fascinating one, which is the story of a part. How does a part become 3D printed or additively manufactured? And we have 3 great experts on our roundtable to tell us each about the story of a particular part. So 3 different parts. I'm going to let our panelists introduce themselves in a second, and later on they'll also introduce the parts and the companies for which own these parts. And then we'll start going. If there are any questions that you want to make sure get in, you can ask them at the beginning and we'll be sure to incorporate them. Or if you feel more comfortable, you can put them in the chat and I'll try to look there and incorporate it. So let's start with our panelists. Angeliki, can you please start?
Yes, sure thing. Hi, everybody. Thanks a lot for being here today. I'm Angeliki Malizou. I'm Castor's Business Development Manager. Yeah, I'm here to present a very interesting case of how 3D printing can help in the production line to reduce cost and to reduce lead time. I don't know if it's the time to get deeper into it, or maybe just a quick introduction.
We can talk about the parts a little bit later, and just to be clear, we'll talk about the parts in general. So
sure.
What the part is, what company it comes from, really every step in the journey across the 3 parts. So Henrike, how about you?
Yeah, thank you. Hello also from my side, also pleasure to be here. My name is Henrike Wonneberger. I am one of the co-founders of Replique, and at Replique we support OEMs to put their parts or to move from a physical into a digital inventory with additive manufacturing, so really getting the parts in and also getting them out in a print. And I work also a lot with customers, and I brought a story of a part from a customer here today, and I'm looking forward to the discussion.
Great. And last but not least, Jordan is battling her voice, so hopefully it'll hold up.
My voice this morning, I was like, oh no. I thank you so much for letting me join. As Lisa said, my name's Jordan. I'm from AMT, Additive Manufacturing Technologies. We're an automated post-processing manufacturer. We manufacture machines that help companies reduce the bottleneck that they have in manufacturing for AM, where the post-processing needs to take place. No more, manual sanding or anything like that. We have depowdering machines and Vaporsmoothing machines as well.
Great. So thank you, ladies. Now, what I would like to do is start, for each of you, please start with the part and with the company that owns the part, and tell us a little bit of background about what does the part do, and kind of why did the company come to you. So I have 1 slide for each one. I'll share it and we'll go in the order of my slides. Hang on. So first is Enrique.
Okay, yeah, so I brought a story of a part from Sienna Garden. So Sienna Garden is a German garden furniture and equipment manufacturer. And basically, I brought more than 1 part, because what we did together with Sienna Garden was qualify parts for additive manufacturing with the idea of having the eternal spare parts. So really for your equipment, like the Hollywood swing or a chair that you love dearly and you want to maintain, and you want to be sustainable, of course, we'll talk about that later too, that you can get them, basically forever on demand and everywhere. So I have the parts with me, and also here It's shown already a little bit that we had to do some redesign from, for example, the original screw.
Let me stop sharing so you can show the
All right.
Go ahead.
Yeah, so basically, but I guess we'll also come to that later. We had to do a little bit of redesign. So we had, for example, this original screw to set this roof of the Hollywood swing to be able to line the shade. And we had to redesign this a little bit. We had two parts. So here you can stick the screw through, and we redesigned it for FDM printing. And yeah, that's just one part, of course, because if you do not have that part, you can't really enjoy your Hollywood swing that much. You'd have to buy a new one, which would be quite expensive. But we also did a lot of other parts, so like little foot caps. I just brought one from the chair Luzern, which originally looked like this. And we also redesigned that a little bit so it could be printed support-free in FDM from ASA.
Very good. So I'll go back to sharing and we'll move on to the next one. The next one is Angeliki.
Great. So this is an example from Stanley Black & Decker. It's actually a division of Stanley called Stanley Engineered Fasteners. They have a very, very, very large portfolio of fastening products, and they came to Castor, which I was a bit cryptic about what we do, but they came to Castor because they wanted, as many manufacturers want to utilize the benefits of 3D printing. One of the common challenges manufacturers identify is they might have a very large portfolio of parts, is selecting the parts that make sense to 3D print, both from a technical, but also from an economic perspective. So that's how they came to Castor. Castor has a software that enables that. So what happened is that Stanley analyzed a number of parts and assemblies in this production line. This is a production line for helicoils utilized in aerospace industry, in automotive industries. And they came to Castor, they utilized the software, they analyzed a number of parts, and they found that this part that we see here on the left in action, this is a machine that produces helicoils, and this is actually where the helicoil is developed, around that little part. We see it on the close-up on the right. Right.
And this is the part in question.
Right, and then we see on the right, we see it on a close-up.
Yeah.
So they identified that as an opportunity to 3D print without any design changes, and it was both a cost and a lead time opportunity.
We'll get to that.
Okay, spoiler alert.
Spoiler alert, we'll get to that. All right, and last but not least, Jordan.
So the company that uses this drill, or at least manufactures this drill, is West Coast Industries. They're an aircraft and aerospace tooling manufacturer. So the company that they were designing this particular part for was quite a large aircraft company, which I'm sure you all know, but I can't actually say. And what they needed was a handle, because what was happening during the process of using this drill was the engineers' hands were getting very, very cold. What happens is 25 HP compressed air goes through this handle. And
this is the tube, right? This tube has very cold air in it.
Yeah, and people were dropping it because it was so cold.
And they were dropping it because it was so cold, and the handle wasn't doing a good enough job. So this is the original handle.
There's actually sort of a smaller handle just before that as well. And what this drill does, it drills precision holes in like wings for airplanes. It has to be very precise because the load needs to go exactly equal across all the bolts, and if it doesn't, obviously then you can get cracks and things, which is not what you want in an airplane wing. And so obviously having this drill be usable, because a lot of the times people's hands were too cold to use it, they were dropping it, that was causing a lot of downtime and things, so they needed another solution for this handle, so people could handle the equipment correctly.
Yeah, and this is the handle itself. This is the 3D printed and processed.
And smooth, yeah,
Yeah.
absolutely.
All right, good. So as we see, we have a combination here. All of them are really existing parts. It's not anything new that was designed from scratch for additive. So this is a harder case, right? It's a case where they already have something in place and we need to replace it. But we know that they had problems with each and every one of these parts, which pushed them into additive. What was the problem, Angeliki, with the jig? Was it just going? Was it hard to machine? Expensive?
No, in reality, what the company knew is that there low-hanging fruit in additive. They understood that there is a possibility to reduce cost and to reduce lead time. And it's important to explain that as they are making a number of different fasteners, they need a number of different tools, right? So we have a high mix of products. But also, these tools are needed in low volume. That's the sweet spot of 3D printing. It's a great opportunity. As I said, always the challenge is finding which of those parts are adequate. But in this case, they understood that, you know, we have a case here for 3D printing, low volume and high mixture of parts.
So in your case, yeah, go ahead.
So as I said, the idea is to optimize in terms of cost, but also in terms of lead time in the production line.
Right, because I imagine if they would CNC it probably took a long time. So here we have a high mix, low volume case. In Enrique's case, it's an obsolescence case, right? It's when the part, and we'll talk more about that because in Europe that's becoming more and more of an issue. And in Jordan's case, it's really an aftermarket accessory because the handle turned out to be not good enough. And so really we're talking about an accessory. Instead of replacing the whole drill, you find a solution for the handle that didn't work as well as could be imagined. Good. Now, what I would like to do, I'm going to stop sharing now that we've talked about what each part is, and let's go into the process itself. Kind of when the customers look at this, the OEMs, and they need to bring in a 3D printed part, talk about what their requirements were. Kind of what were the specs that they gave you, and in what terms were they? Were they in terms of strength requirements, or were they in terms of the material required, and the material inherently implies a certain strength? Stuff like that. Jordan, why don't you start this time?
So it was one of our partners, Proto, who has one of lots of printing machines and also our smoothing machines.
Jordan, you need to go closer to the microphone.
All right. So our partner, Proto, they manufactured a glass-filled nylon part, which for this handle, which it needed the ability to have low thermal conductivity.
But how did they arrive at glass-filled nylon? Was the original handle glass-filled nylon?
No, I believe it was an off-the-shelf one which wasn't doing its job. I believe that was something that they had experimented with with Proto.
So really, because they wanted insulation, I assume.
That's right. There was a couple of things that and obviously this was the best one. I'll tell you the things that they were looking for. It was the fact without additive manufacturing, it was the fact that they could have that external shape in the handle, so so it was ergonomic, and also the internal geometry. The hose and things needed to have a very specific shape too, and it needed to not rattle because obviously that could damage it. They needed the impact strength, which at glass-filled nylon wasn't maybe the best, but it met all of the other criteria quite well. And then also the ability to be produced at a reasonable cost as well, of course.
So I hear there was a complex geometry. I hear that there was insulation properties. and there were strength properties that were needed, and of course, to be able to manufacture all that fairly on time with additive. Those were the requirements. And then, so what happened? Because you mentioned that the glass-filled nylon was a material that matched most of these characteristics, but not all of them. So what do you do?
That's correct. So with our post-processing technology, we vapor smoothed the parts. So what that did was gave that additional strength. It also gives it a nice shine as well, and reduces the any water that might get in as well. So it's quite a durable piece of plastic now, which means that when the engineers are using the drill, they don't have to kind of baby it. They can just kind of drop it now, whereas before, when they were dropping it with just the glass-filled nylon part, it was smashing, which obviously then more downtime, people getting colder hands. Obviously, you don't want a broken part on your tool either, and nobody wants downtime and extra cost of buying another handle. So having that that smoothed part, that gave them more impact strength, and you can literally throw it off a building and it maybe gets a couple of scuffs.
Okay, yes, and if somebody's interested, there's also a video of that later on. Jordan will put the link in the chat. So really what you're saying is, or the first insight that I kind of take from that is that when we look at the properties of a part, we shouldn't just take into account, certainly not the original material, because it gets processed in the printer and the characteristics change. But even if there's some post-processing happening afterwards, that also changes the material characteristics. So we need to take that into account when we want to fulfill the requirements for the customer. And I think it was important also that the customer didn't insist on the material, because I know sometimes customers do. And in your case, they really didn't. They were okay with using a different glass-filled nylon. Is not a common material.
No, I mean, vapor smoothing works on a variety of materials. I think in this particular case, it was one that was fitting all the other criteria. But like I say, it does work with an array of materials.
Okay, so Enrique, can you tell about your journey?
Sure. Yeah. So the two parts that I brought are just two out of a set of parts. So basically, you named it. It's about obsolescence. It's about Sienna Garden wanting to enable their customers to repair their products for longer. And so it's a very interesting case, I think, because you would think it's counterintuitive. They should hope that things break and they can sell more. But on the other hand, they say, okay, sustainability is really a big thing, and we want to enable our customers and support them. And usually with spare parts for them, it's when they have new products, they can order a set of spare parts and they have it in stock. In the beginning, nobody needs a spare part because obviously they've just bought a new product, and then you have, for a while, you have it, you have some demand and you have it on stock, but then later on, when people really want to repair, then you don't have it on stock anymore, because either you're sold out or it's been lying there for too long with polymer parts. You might even, you have to get rid of it because the quality is not there anymore. So you really have an issue then of getting the parts. And we heard from Angeliki also, smaller volumes. Usually that means you have high cost per part. So what usually happens is that for an OEM, it's really hard to offer spare parts for a long time to their customers at a decent price, so to say.
Talk about the requirements in your case.
Yes. So the requirements, obviously, sorry for the destruction, was for garden. So we needed to find something that was UV resistant for sure, and weatherproof, and also it needed to be sort of in line with the design of the original product. I mean, if you have a screw, you want it to look kind of okay. So you want the same color or similar color. And last but not least, and that's why I made this little excursion in the beginning, you needed this to be somehow cost efficient or cheap enough to qualify for a consumer part that is ordered on demand. Because what happens with Replique is that These parts, they're in a web shop, and when somebody in the Siena Garden web shop actually, and when somebody orders this part, so a Siena Garden customer orders the part, this is being produced. And so it's not about storage, it's really about a digital inventory. So this was kind of the requirements we had, and this is why we very quickly ended with FDM printing in this case, and we ended up using ASA material and a TPU. I'll come to that in a second also. So the ASA for certain parts, but the TPU, especially in the case of foot caps. I showed you one foot cap, but I also brought another one. I don't have the original with me because it's hard to get the originals still, but here you can see that it's kind of flexible. It's very nice for a foot cap because it also has this rebound effect. And this was actually a TPU from our colleagues Forward AM at BSF that was not even launched at the time, the TPU 64D, but we were able to qualify this already with our customer.
Right, and I think we need to remember to talk about qualifications later on because that's very important. But again, it's not exactly the same material as was there in the original, correct?
No, I would guess so, because actually this was very nice. We did not have a customer who said, we have this material, please use exactly the same, but we really had a very good understanding from our customer, who, by the way, also did some 3D printing themselves before they have a small lab, and they did first test themselves, and they really understood directly this idea of, okay, you have certain requirements from the application and you find the right material for that. So that was very, very good and very easy, actually.
Great. Yeah, and I think that that's something that you have in common with Jordan's story, because really, when people insist on a particular application, it's much harder. On a particular material, I mean, it's much harder. And sometimes you can find another material with the same properties and even looks the same to the untrained eye and can do, the same job. So Angeliki, can you talk a little bit about the material in the part?
Yeah, sure thing. I must say that there is a common thread here, like in the case Enrique presented and Jordan. We also didn't have a very strict requirement, or I would say on the side of the software user, there was the understanding that we are looking here for additive manufacturing opportunities. And this case kind of illustrates how these opportunities are unlocked if we are not looking for absolutely 100% equivalence. This is not how additive manufacturing needs to work, and I'll explain why I say that. So the traditional manufactured part, the CNC part, the one we saw earlier on, was made in tool steel. Stanley analyzed, as I said, a bunch of parts through the Castor software, and one of the kind of piece of information we give is what is the recommended printable material. In this case, it was margin steel, which maybe is not 100% equivalent with regards to strength, but in the end of the day, it wasn't necessary for this application. And sometimes this is the case, right? Because this part was designed for traditional manufacturing. There were certain requirements put in place, but it wasn't necessary. And actually, for this case, to have exactly the same strength. So they moved to margin steel. They were able to reduce costs. They were able to reduce lead time. And also they went through the verification process, right? They tested the part. They tested the impact on the part on the final product. And it's all good, and they keep on.
Was there any discussion about this with Stanley or with any of your other customers, where initially they wanted a particular material and then you kind of introduced them to the idea of an equivalent property-wise, but not equal material? Or did they come already cooked with it?
In our case, it is part of the information that they were able to extract. It's part of the additive manufacturing thinking that the software promotes, that you see a comparison of the different material property by property. So the traditional material and the one recommended for this application, and then the engineer who has a better understanding of the final application can make the decision. And I think it's it's core in the adoption of the technology to understand that we are not looking for 100% equivalences. That we are looking for a new way of thinking that can unlock a lot of possibilities.
Yes, I think we're looking for equivalent properties rather than equal materials.
Exactly.
And I think Enrique also echoed that sentiment from our customer. And Jordan, do you know if Proto was open to this, or was it just the fact that they tried the same material and it totally failed?
I think with Proto, they had compared lots of different ones at the time, but I know AMT, we've done that before in other applications where people have come needing, say, a food safe product, and they don't really know where to go with AM, and because our sealing, our chemical vapor smoothing solution does actually let a lot of the materials that previously aren't food safe become food safe because of that smoothing. We've been able to recommend people, they're able to use a different, cheaper, often solution because of things like that. In this particular case, I believe that one was the one, I think probably because of the pricing. But like I say, we've been able to do that because of the extra solution that we have.
Yeah, so I think that's that's a very important takeaway from this step of the process. Now let's talk about the kind of who did what and why in your process. So who did the selection? Why, like, and why, if it was if there's something interesting there, who did the design or the redesign, and who did the actual execution, or certain steps in the execution in some cases. So Jordan, since you're up there, why don't you start?
So like I say, they didn't have a great solution beforehand. It was a lot to do with Go Proto. Obviously, they spoke with our engineers.
Go Proto is a prototyping.
Yeah, they're one of our partners. I believe they sell printers, and they also sell our solutions, and they can also do manufacturing.
Do they have their own service provider in house?
They are.
And they also have design services. They also did the redesign.
I believe, yes, they did. Yes, they did in this case. Sorry, I've had.
Okay. And did they do the post processing with your machines, or did you guys do it?
No, they did the post processing with their machine, and obviously we were able to support them with that and give them ideas for where they needed to go and look at the parameters and things for the particular type of materials they were looking at.
Okay, great. Angeliki? So in our case, as I mentioned, the selection happened through the software. It's actually the primary goal of the software. The production was made through a service bureau. So the company commissioned the part through an external provider. Actually, this is the first metal part that Stanley implemented.
Do you know who the provider was?
Yes, the provider is called FIT America.
Mm-hmm.
And it was printed, yes, in a DMLM printer. Mm-hmm. As I said, the company was looking into the benefits of additives, so they commission external capabilities for the final product, but it was very interesting in this case.
And also they have internal capabilities, as you mentioned.
Yes, right.
But because it's metal, maybe.
For this part specifically, and in this facility, it was they had an understanding that 3D printing can be beneficial, but they wanted to find on a larger scale. And yeah, they were able to slash the cost at 50%, so not bad, and to get it.
Yeah, no, but I'm saying that even though they had internal capabilities, they went externally probably because it was metal, because I think their internal capabilities are mostly plastic.
At that moment, yeah.
Yeah, that's
at that moment.
That's what so they really went to an external service provider to provide them the parts. That was the process.
That's right. Yes. And nevertheless, yes. Even that way, I think that's perhaps interesting to say at this point. Even that way, they used to get it CNC'd, right? And they were waiting 2 months for it, and they got it in 9 days.
Yeah, so that's 2 months down to 9 days, even though it wasn't manufactured in-house.
Yeah.
But the design was done in-house.
The design, and I think that's another interesting point in this use case. There were no design changes. This is really low-hanging fruit for additive manufacturing that for many companies will remain unrealized unless they have the possibility to discover the opportunity, for printing. But there was no design changes in this part.
Yeah.
There was a change of material, but no design change.
Yeah. So it was really the work that they did in-house on the design side, and then they went to an outside service provider to execute it. Enrique, how was it in your case?
So in our case, we first of all discussed would these parts generally be printable, and of course parts like foot caps are very well printable. But what we then did together with the customer was we said, let's focus on really the parts that give you some supply chain pain. So more coming from the business side of things and saying, let's first take a look at parts that are hard for you to get, you don't have a supplier, or for some reason you have problems or issues with that supplier, or it's just simply too expensive because maybe you'd need a new molder or something that is kind of prohibitive because you don't need that large numbers. So we identified a set of roughly, I think, 15 parts to start with, and we really looked at all those parts, and they were printable also without design changes, most of them, but then they needed quite a bit of support. So with the foot caps, for example, it's something that is reoccurring. You always have these lamellas that you stick in, and let's show you in the original, you would have to print it with a support.
Because it's horizontal, completely horizontal.
Yes, but what we did was that we kind of introduced those curved lamellas, and we could print them completely support free. Same thing with the foot cap it's completely round shaped. The bottom, I hope you can see this.
Mm-hmm.
It was pretty easy redesign to just, introduce a little bit of a flat area to really print it without support. We just, of course, had to make sure that it still works in the application. So application testing was, of course, part of the qualification process. Mm-hmm. And regarding the redesign, I think we were really lucky because in this case, our customer also had their own experiences in 3D printing. And we actually had discussion rounds. We said, let's do it like this. And so basically, in the end, most of the design changes were made by our customer, which is something that we could have also done for them. Of course, we have engineers who can do that, but I think it's always good if it's coming from the customer themselves. And so that worked out nicely. And really for the foot caps, we could really develop some design principles, so to say. And then, of course, we also had other parts that were a little more individual, and we had to do some thinking. Then the material selection was something I believe that came mainly from us. So, of course, the requirements came from the customer, and then we had a little bit of a discussion. Okay, what do you usually do? How do you test also? How do you do your qualification in-house testing? Is it just a drop test, or what do you need to do with a foot cap? And so this was, I think, a very good dialogue that we had, and we were able to find a good way in printing for all of those parts. They were onboarded into the digital inventory at Replique. And basically, that was fall last year. Now the garden season is starting, and we see the first orders coming in. And of course, that's very nice and very encouraging to also now look for the next best set of parts. So maybe the ones that give a little less pain, but are still very interesting for the customer to offer to their customers.
Mm-hmm. And in terms of who does what, really, you provide the customer with the service providers to print it, right?
Yes. So basically, the idea with Replique is that we do a very thorough qualification process, and we define exactly how we want to print it, the material, the machines, the parameters, and all of that is then sort of frozen. It's the clearance of the customer saying that's exactly how I want it. And then with our partner network that is globally distributed, we can make sure that we can provide the parts to the customer where they need it and when they need it. So it's not one provider, but if that one provider, would be full, we would have another provider who can print exactly the same quality.
Yeah. So I just now realized that all three of these stories, none of them are actually produced in-house. They're all produced at a service provider that specializes in 3D printing in different ways, as you saw. And I think that also some of the redesign that's needed, whether it's in terms of thinking of the material we talked about before, or about the geometry, some of it is, of course, repeatable. Because how did you call that, like a lamella?
Yeah, I don't know if that's the correct term in English, but
I would have said the little ridgy thingies, but
yeah.
Whatever. It's just it seems to me that is something that's repeatable, having in mind to keep the price low, so that if you don't have support, the process is easier, you use less material, it makes everything cheaper. And these are really small changes. Now, before we move on to the results and kind of what did the customer get out of it, do any of you have any kind of stories about the champion? There's usually in the OEM, there's a champion who is the one that pushes AM forward or pushes this forward. And I think a lot of times it hinges a lot on your champion. If you have a good champion that really is, first of all, well connected within her or his own organization, but also a champion that really gets it, I find that makes a big difference. Have you had any stories where really the champion gave you a specific push or tip or something important that made the project really work? Anyone? No stories. So I'll yeah, go ahead.
I would say that it needs a champion, like you say, Libath, who has the right mindset. And I think, Angeliki, you mentioned this too. You just have to try it, and you have to, be bold enough to move away from traditional ideas of traditional manufacturing and supply chain. And in that case, so I think we had this wonderful combination with our customer of not only having the AM experience from a technical perspective, but we also had this champion in the management who pushed this project and said this is a great opportunity, and we can really leverage the potential of additive manufacturing with this digital warehouse idea of Replique, and also enable our customers, because I think that's a very interesting twist about this story, that here it's, and you might come to that point later, the parts are more expensive than the original spare parts, obviously, because they're not injection molded in thousands and thousands of parts. But in the end, it's the decision of the individual user. Do I want to repair my chair, which cost me 200 euros? Do I want to repair it with a foot cap that maybe cost me 5 euros? Is it worth the money? Is it personally for me? It's not a decision like a foot cap has to cost this or that. And I think that's a very, very interesting and very innovative way of thinking also.
So I think what you're saying is that sometimes the champion is also somebody who's a business innovator.
Absolutely.
Not just a technical expert or a manufacturing expert or a supply chain expert, but really somebody that thinks about business and innovates in business. And I can tell you that in my experience working with amazing champions in different companies, and some of you know some of them, I think it's very helpful to give your champion some, I'll call it small help, which is sometimes creating a slide in their style that explains what's proposed here in a way that's easy for you to put together, but maybe harder for them. And so when they go to their management, they have an easier time and maybe present a more concise kind of picture and pitch. And I've had feedback from champions where that is very helpful. And that's something that unfortunately not enough companies do. What they do is they provide you their material, like the supplier's materials as they are. And that's not helpful for the champion. The champion needs it to be specified for their case and from their point of view. So that's just something I wanted to add there. So now we should move along. Before I move along, if anybody, again, if you have any questions or any comments or want to add anything, please add from your experience, because I know that there are some experienced people in this audience and that have gone through this journey, and I really welcome your input. So now let's move on to the results. So some of you have touched on it. Angeliki, you mentioned shortening of the wait time, right? And also the cost. Can you give us some specifics?
Yeah, sure. So this is a very straightforward example. This part used to be procured for $120, and Stanley was able to get it through 3D printing for half the price. So for about $60. As I said, is a low volume part, but there is a high mixture of fasteners produced by Stanley, and hence a lot of different tools and jigs and fixtures involved in their production. So you can imagine that the benefits can be multiple for the organization. So it's a very straightforward case of cost reduction and lead time reduction, hiding in plain sight, and that's where the collaboration also was able to enable them to find this part and to realize this benefit.
So do you know if they keep producing this part?
Yes,
they do.
They keep on utilizing 3D printed parts for
this application. That's, you know, that's the proof in the pudding. If they continue to do it and if they add more and more parts, that is the best show that this is actually working. And it's the best kind of vote of confidence. So Jordan, would you like to talk about some metrics for your part?
I think rather than a numeric cost with this part, because it was quite a change from what was there before, it was more the loss of downtime. You know, once they'd got the final smooth part, if they dropped it, they didn't then have to go and get that changed, which then put the machine into downtime, which then put the project back. So it was more of that time.
Give us a ballpark. How much downtime is it, A, to replace this part, and B, to get it if it's not 3D printed?
So if it was maybe not in stock, obviously they would need to get that 3D printed. Obviously Proto, they provide solutions, manufacture these durable parts. So they would have to get that from Proto, who are fantastic at their turnaround. But as I say, you've still got to wait for that. But you've obviously got to take the part apart. You'd have at least 2 days, even if you had the part, where you would have to, you know, downtime, make sure the actual machine wasn't damaged because of the drop as well. So having that means that they don't have to replace it. They can clean it easier, so they don't have as much downtime in the normal standard maintenance of the machines. Obviously, it improves the aesthetics, which in this particular case isn't that great, but it is in some other consumer parts. It also it reduces the cost of maintaining the spare parts as well, because you're not having to worry about making sure that they're still viable for it with just the nylon on it, so the glass-filled nylon on its own. So there's, while ours maybe were probably around the same price for what they were looking for, it's the downtime that they're not losing anymore that is the win here. It's been a great solution for them, and their handles are still on the machines that they're selling now to various other customers as well. So it's been a win for this particular project, but also when going forwards with other customers for our companies.
Yeah, so what I hear is that it came out at a similar cost, but it really saved on the downtime. And if you think about this, these are working tools in the aerospace industry. So these are expensive tools. When they're down, you need to bring in a different tool. You can't just let the plane wait for 2 days for, you know, for somebody to come in and drill a hole.
Exactly.
So this is very expensive, actually, the waiting.
You can't take on as many projects if you've always got to make sure you've got X amount of spare tools. Or you have to make more tools, which is then another cost. So yeah, it's amazing how things can snowball really with something like this. It seems quite a small thing, but actually it's a huge impact on a business.
Right. Okay. And Henrike, you already mentioned the change in business model, but and in your case, the part is actually more expensive, but it's available. Well,
Yes.
the alternative is not. So how do you compare that? And what does that mean for the consumer? You know, in the end, the OEM has to go to the consumer, right? The consumer, I presume, when it wasn't available, was not so pleased, you know, to have a how do you call it, a rocky chair because one of the cups is missing. That's not a very good consumer experience.
Yeah, I was thinking, what's the metric here in my case? Because yes, it's more expensive, the spare part now, for good reason, and but it's available. And I think in the end, the metric is customer satisfaction. So being able to offer those parts that before, you know, you weren't able to offer unless you really subsidized them. I think that's very important, and ultimately supporting the customers to repair and therefore save resources, because this is becoming more and more important in our society. And I think, I mean, you mentioned this.
More about that.
Yeah, you mentioned this in Europe. So we have in some areas, not in the garden furniture area yet, but in the white goods, for example, we have the right to repair, which also it's a legislation now that forces OEMs to provide spare parts for a certain amount of time.
I think 10 years, right? A long amount of time.
And so that's one thing. And another thing is that we see other trends like the repair index coming, where at the point of sale, you know, you're trying to explain the customer already how well can something be repaired. And I think this is just the starting point where we're at. Currently, it might still, you know, be a trend in the consumers, sort of in the society, but it's going to become more and more regulated. Is my personal belief, and it's a good thing, because ultimately, if you think about sustainability, I think repairing and, you know, not throwing away and using new resources to build something that is still quite good, I think is one of the largest impacts that we have. So I think it's an excellent trend
in that respect, in sustainability respect, because you don't have to compromise on something less comfortable. It's the swing that you know and love. You've just repaired it.
Yes, and if you think about, I mean, I said it's more expensive. Yes, it's more expensive than the original spare part was when, you know, your swing was bright and fresh and new. Maybe you were clever enough to, I don't know, buy lots of spare parts and stock them in your basement. But at the same time, if you think about buying a new Hollywood swing, then, you know, it's 300 euros and above. So actually, it also saves you money as an end consumer. So I think that's maybe also a metric, saving money for the end consumer because you can repair.
Yes, and also allowing Sienna Garden to have another revenue flow, maybe. Because when a consumer buys a new swing, it could be Sienna Garden, but it might also be a different brand because he couldn't find a simple thing to repair the existing swing.
Yes, and maybe you buy Sienna Garden furniture now because you know that you can repair for longer, and also good that you're mentioning it. In this concept, the real effort for the customer, for Sienna Garden, so our customer, let's not confuse them, is this process of qualification. But once it's qualified, the part is there and it's, you know, it's printed more or less on demand. And so they don't really have capital that they have to spend up front. They don't have stock. So basically they earn per part.
The process costs money, doesn't it?
Sorry, the qualification. Yeah, well, it does. Of course, it costs money. Depends on what you do yourself and if you know exactly what you want and you hand it over to us and you're good to go, then that's pretty easy. But if you want a little bit of support, yes, obviously it costs a little bit of money, but I think what's even more important, it costs your own resources. I mean, you have to qualify those parts, you have to test them according to your own test protocols. And so I think that's kind of the upfront invest. But then once it's done, it's done. And with every part that you're selling, you can earn money because it's up to our customers, of course, to set the price.
I think people often forget that you need to qualify parts, even if it's not FAA or FDA, strict, I don't know, year-long or whatever qualification. There is some internal qualification that parts go through at the OEM. And I think that people often forget that when they plan the timeline of this story. It's important to remember. And I think the one place where it's a little bit alleviated is in tooling, right? Angeliki, I assume that this tool did not have to go through too much qualification beyond the material properties.
It went through it went through testing to check dimensional accuracy, but also if there's any impact on the final product, as I said, on the helical. Well, there were also such clean cut benefits that
and also that's relatively light qualification compared to people that need to qualify material process, food safety. Jordan mentioned that's a more rigorous qualification usually. So normally jigs and fixtures have like strength requirements and, as you said, geometry, fit, and stuff like that. But those are the kind of the lower bar of qualifications. And that's also what makes jigs and fixtures a very, very attractive application to start with.
Exactly, and also to demonstrate that there is a business case within the organization to create momentum, to find more champions, as we were saying earlier on, because it's important. I think one reflection I had along the discussion from that point on is that it's important to have a champion in the management, as in the case that Henrike was presenting earlier on, and also in the technical engineering team. And I think that's the way to get more champion. Yes, to get more people on board in the additive manufacturing journey. That's our experience as well.
Yeah, that's very, very good advice in my opinion. Jordan, do you want to say something about food safety qualification? It doesn't have to do with this particular part, but I think when we talk about qualification, it's a kind of qualification people sometimes overlook is the food safety, or I forgot what it's called, if it can touch the skin or if it can touch like the inside of your mouth. That's beyond food safety.
Yeah, so all three of those actually are things that we've done qualifications for. With parts they have to be, the actual part has to be qualified. So it's for the specific use. So I know a lot of people will say that their material or their process is qualified with both US and European qualifications, but actually it's the particular part that needs to be qualified. So for that particular use with that particular material and any processing that's done to them, we've worked with a range of companies. We've had dental companies for parts for false teeth, for example. We've had spectacles, eyewear companies. We've worked with.
So all of these are all in the same qualification area, right?
Yeah, I mean, obviously we have slightly different testing. We've got slightly different levels that they are tested to, but they, you know, they're all sent to the lab. You've got to detail each part of the process that the part through to get there.
So we're almost out of time. So the last thing that I want anybody in the audience or on the panel, if there's one tip you could give an OEM going on their path or on their story for their part to aim, what's your number one advice? Angeliki, you start.
I think I mentioned also in the beginning, it will not try to find identical replacement. It try to embrace a different way of additive and not to see it as a competition to traditional manufacturing, but to see it in conjunction with traditional manufacturing. Because that way, I think we overcome the obstacle of this being a threat full of risks, and we see the multiple benefits when considered together with traditional.
Enrique?
Yeah, so my advice would be bold and first of all, be bold and check, see for a business case first, but check for a business case, not in the way that you compare part price, but that you compare all costs that are related to a part.
Including
and they can supply chain, anything and even customer satisfaction, if you can put a price tag on it. And so think of it as a holistic journey, and think of it, it's not about, you know, I showed you some very simple parts in polymer. I could have shown you also very complex parts in metal. We've seen many parts and we've done many parts, and they're all very different. Each part has a different journey, but make sure from the beginning that the part is worth the journey, and then it's going to bring a lot of joy.
Great. And last but not least, Jordan.
I would say actually a really good thing to do is to listen to the experts. Like, I know obviously we're all here and we're all promoting different things, but I think go and find those people that can help you with this sort of thing, because I know all the companies that we work with are happy to give that information so you can make your own decision on that, and having those tools and being able to decide between the different areas, you know, that does allow you to, like you say, build the business case and also take that step into additive manufacturing if that's the way that you work.
Okay. Anyone in the audience want to add something?
Yeah. So first of all, thank you very much for this discussion. I have learned quite a lot of things. I think the digital warehouse is a very good way to educate customers with this technology. Usually you find something in a warehouse you can implement with additive, and they learn this flexibility and to think more additive. So this is the right thing to do. But today I got the confirmation that additive is becoming more competitive. Angeliki, I was very surprised saying that the part was cheaper. We have more materials available, and availability at the point of consumption is becoming the argument for additive manufacturing right now, more than cost. And the second thing we will have a discussion about that is the role of design, because now we are talking about circular economy and second life of products. And if the designers start to think, okay, what is going to be broken? And how easy can I repair this part? I think we have an opportunity with additive manufacturing. It will be interesting to discuss that with all of you.
I think those are awesome points. I would have loved to discuss that even further. Unfortunately, we're running out of time. Anybody else want to say something before I wrap it up? Okay, so I'll just say from my point of view, I agree with all of you. My emphasis is together with Isabel and Enrique on the digital warehouse. I think that is a great way, because I think that the supply chain and all the supply chain failures so far give us a huge opportunity. And the legislator in Europe with right to repair has given it a big push. I think it's amazing what you said, Isabel, about the design. That's something I hadn't thought of, and I think it's very important. So I think there's a lot more to discuss. Thank you all for coming here. This roundtable will be available soon on the Women in 3D Printing YouTube channel, I hope, and I will update all of you when it is. So thank you very, very much, and have a great day.
Thank you.
Thank you.
Thank you.
Thank you, everybody.
Everyone.
Bye-bye.
Bye.